Hey everyone, we'll give it 1 or 2 more minutes and then we'll jump right into it. Okay, I think we'll go ahead and get started. So thanks so much everyone for joining us for this Tech Tuesday. We have a good one for you today. It's going to be led by Zhang. He's one of the co-founders of Kaleido and a very, very, very deep subject matter expert in all things Hyperledger Fabric. So former maintainer of the protocol and has contributed a lot to all things on the surface, including the Node.js SDK and many, many other features. So I'm very excited to participate in this one. Few pieces of housekeeping. This is recorded. It's also being live streamed on YouTube. So give us about 24 hours after the conclusion of this and we'll be sending it out. You can, of course, visit the Kaleido blockchain YouTube page. We have a library of all of our previous recordings, handful from Jim, bunch from myself, and many, many other engineers on the team. So it's a great treasure trove for additional resources and refreshers. We love for these to be as interactive as possible. So don't be shy to post any questions into the chat or Q&A. And based on time, we'll, of course, do our best to save 5 or 10 minutes at the end for any additional real-time questions. So with that, I'll turn it over to Jim to jump right into all things about how to write, test, deploy Chaincode and how that functions with the Kaleido platform. So Jim, take it away, please.
Sure. Hey, Nick. How's it going? Hey, everybody. So thanks for the great introduction. And Nick was being modest. He was also one of the earliest contributors to Hyperledger Fabric. I'd say very close to the OG. So very happy to meet you guys virtually and talk to you about the Chaincode aspect of Hyperledger Fabric. So as you know, it's a very popular protocol within the enterprise space for all the DLTs among the enterprise use cases. We have seen a lot of adoptions across the world of this protocol in all kinds of industries and use cases. Chaincode obviously is a very important component in the architecture. So we will give a quick overview of what Chaincode is and how does it compare to the other smart contracts in other protocols that are also being used in the enterprise DLT space, in particular enterprise Ethereum and Corda. And then we'll dive into a bit more details of how to write a Chaincode, how to deploy them. And finally, by then you will realize, yeah, it's very powerful, but it's quite complex as well. So we'd like to introduce to you guys is there an easier way to deal with all this complexity? And in particular, using Firefly, which is another Hyperledger project, as well as the commercial offerings from Kaleido. So I assume a lot of you may have heard of Fabric or even use it or even have it in production. Fabric Chaincode can be loosely thought of as the smart contracts, right? Smart contract is a term that's popularized by Ethereum, the very first blockchain that supported smart contract. Smart contract is the concept where a bunch of business logic is captured in the blockchain itself. So when this is being executed, it's not executed in the centralized environment where nobody knows outside of the centralized system what is being done and whether the right logic is being executed to execute the transactions. Smart contract is completely open and transparent to all participants of the blockchain, so that you know exactly when a transaction is submitted to the blockchain, what kind of logic is being used to process the transaction. This makes it a great choice for implementing common logic within a consortium setting. It's a great construct to launch a token in the public space, because how a token is managed needs to be seen by everybody, so nobody can cheat in the whole ecosystem. Hyperledger Fabric also has the layer that supports smart contract. It's called Hyperledger Fabric Chaincode. I said it can be loosely thought of as the smart contract as seen in Ethereum, because there are some subtle differences, subtle but also important, and we can look at what they are, how they're different from Ethereum. Yeah, so as we mentioned, Chaincode implements transaction processing logic, and it's the critical piece of this compared to previous IT systems in the centralized architecture is the logic is shared by all the participants of the Fabric blockchain. And how that's enforced, so we all know when something gets processed, we're all using the same logic, is guaranteed by certain properties of Chaincode, and we can look into more details how that's guaranteed. And finally, as you may recall, Fabric architecture has orderer nodes and peer nodes. Orderer nodes is the sort of the central beating heart of a Fabric blockchain. It maintains the consensus algorithm and maintains all the transactions. That's where all the transactions get sent to. But peer is also another critical component in Fabric, which on one hand manages all the ledgers, so all the DLTs for the distributed ledgers for all the channels are managed by peer nodes, as well as executing the Fabric Chaincode. So all the Chaincode are deployed to peer nodes, and this is where the logic is executed. By the way, if you have any questions, go ahead and raise your hand or send to the chat, and one of our panelists will bring that up. So at the very highest level, a Chaincode process talks to the Fabric peer node through HTTP. So this design is quite unique. It's pretty different from many other blockchain designs. In particular, Ethereum, for example, the EVM engine, the virtual engine that executes smart contracts, is a in-process component on the nodes. So each Ethereum node has a sandbox area where the EVM runs, and it runs in the same process. On the other hand, Fabric decided that Chaincode should be isolated as separate processes, and they talk back and forth with the peer through HTTP, and there's a standard interface between them. So looking a bit more into how a Chaincode process talks with the Fabric peer. So when you deploy a Chaincode, you bring out the process. And this process can be running inside the Fabric peer in the same VM or in the same Kubernetes pod or in the same container, but it's a separate process compared to the Fabric peer. when it's deployed, it's told about the location of the peer. This is where the peer exists on the URL host name and port. And these are the parameters you have to use when you communicate with the peer. So on startup, Chaincode will register itself to the peer and say, hey, if anybody wants to call a Chaincode call by this name, let's say my Chaincode-1, talk to me. And then, as in the diagram, another process may register themselves as the Chaincode for the second name, my Chaincode-2. So after this registration, Fabric peer would know when it takes a transaction request, let's say in this example, that specified the Chaincode ID being my Chaincode-2, it knows it's going to forward this to the process on the bottom, which registers itself for that name. And then it forwards all the transaction parameters to the Chaincode process, and then takes the output from it, and then handles the update of the state within the peer. So as you can see, the peer itself is a dispatcher of transaction requests, and also it's a collector of Chaincode execution results, so that it can use it to then talk to the orderer and then replicate blocks and then update transaction states. So I saw Jim raise his hand. I don't know, Nick, Kevin, Mess, and it makes sense to bring up the question now or save it for later.
Yeah, I think we can go for it now. Jim, I'm going to unmute you if you want to throw in the question.
No, that was just a mistake hitting the hand raise. I was trying to close the chat. Thanks.
No worries at all. If anyone else has any ad hoc questions, though, don't be shy, please.
Awesome. Hi, Jim. We've met a couple of times on some other forums. Great to see you. Okay, so let's look at one level deeper into the Chaincode process. So a Chaincode, as you implement it, needs to work with a bunch of other libraries that Fabric provides. In particular, what's called the shim layer. The shim layer is the library that implements the standard interface over HTTP with Fabric. So as you can see, your Chaincode implementation does not talk to the Fabric over this native protocol directly, but it goes through the shim. So your interface is really with the shim itself. And we'll look at in later slides what that interface looks like. And your implementation can be done in any of these languages, either Golang or Node.js and Java. So unlike many other blockchain designs where smart contract has to be written in a more constrained DSL, domain-specific language, Fabric Chaincode can be written in the native language, meaning it's full language, so you have full access to the whole language feature. So Ethereum decided to invent its own DSL to write smart contracts, as well as many other blockchain designs, is because it's a critical aspect for a distributed system of determinism. Ethereum's design is using a pattern that does consensus first and then execute the transaction second. So the order is determined first, and then execution is done individually within each node. And it's because of that design, it's critical that the smart contract implementation must always be deterministic, meaning when it's executed by each individual node, they always produce the same result. Otherwise, every node will end up having a different state, and a massive fork will happen and the chain will be stalled. Fabric, on the other hand, because it's designed on a different distributed system pattern that does the execution first and then order next, and finally applying the values last, it still requires determinism, but it doesn't depend on that. Meaning, if you implemented a bad chain code logic and it's not deterministic, Fabric can tolerate that. The chain is not going to stall. So because of that, when you implement your chain code, you have the full library of each language available to you. Of course, it doesn't mean you should use all of them and write non-deterministic code, but errors happen, programming errors happen. You could end up having a non-deterministic chain code implementation, but Fabric will tolerate that. So another interesting aspect of chain code is send versus query. Recall back in Ethereum, I assume some of the audience may have dealt with Ethereum as well. When you send a transaction, you call Ethereum send transaction method or Ethereum send raw transaction method. Both of these methods will cause a transaction to be kicked off on the node so that eventually a state will be updated. If you want to instead just query the node for the latest value, meaning you're not interested in affecting the state, then you call a different method with Ethereum, ETH_call. So that gives you the answer right away rather than sending a transaction through the consensus algorithm. With Fabric, it's quite different. When you send a transaction, it's actually a two-step process. As I mentioned, Fabric lifecycle for transaction is execute first and then order second, and finally apply and validate and apply. So the execution phase is the client needs to talk to a number of Fabric peers to say, please call this chain code and then tell me your execution results. And then the client will collect all the execution results from the contacted peers and then package all that into a transaction object and then send it to the orderer. So the transaction is always sent to the orderer. So the orderer can then do the global ordering and then package it into a block. So the block can be replicated and then the value can be applied to the local ledger on the peer. But notice that it's really a two-step process, execute first and then send the transaction to the orderer that has the execution results. So that's sending transactions. What about querying state? Well, querying state is basically just call my peer. I want to ask my peer of a particular value that peer is maintaining. I just call it and say, please tell me your current result. And I have the result, that's it. There's no further actions required. And if you want to not just trust your own peer and want to make sure your own peer has the same state value as the other peers, then you can ask other peers for the same state. So you call the other peers of the same chain code method, and they also give you a result. And then you can compare them and see if all of them is maintaining the same state for this chain code. Sometimes this is called a strong read. All right, so let's dive into code. What I'm showing you is the API that are at level 2.0 of Fabric or later. 1.x of Fabric, things look very different. But majority of the landscape is adopting 2.0 or above anyway. So let's focus on this. So as I mentioned, your chaincode itself is a separate process. So the main entry point to your chaincode is basically instantiate the chaincode instance and start it as a listening server. I'm using Golang for this session, but as I mentioned, you can write the chaincode in other two languages, Node.js and Java. So that was sort of the entry point to kick off the chaincode, and this is the internal chaincode library. It inherits from the base contract. As I mentioned earlier, there's a shim layer that understands the interface between the chaincode process and the peer process, and that's what this base contract is doing. So on top of that, you first of all think about your state variables. What are the kind of data you want to capture and manage by the chaincode? And because it's built on full languages, you can use the full language constructs to define your data structure. In particular with Golang, feel free to use structs, not just primitive data types to define your variables. So in this case, I'm using the asset transfer example that's available on Hyperledger. So the state variable is just an asset. It's got a few properties, and the property themselves can be structs, so there can be embedded levels. Next step is you define your transaction functions, the functions that will be called to process transactions. And that takes in a standard interface and then an arbitrary number of arguments. So you can use string or bytes or other primitive language data types. So all that is available for you. So if you want to use, let's say, embedded data types in your input parameters, then you have to make sure you know how to serialize and deserialize them properly, because bytes will be used back and forth to transmit them. And then you can declare events. So set an event when you have successfully processed the transaction, so that applications can listen for events and then understand that their transactions have successfully been mined into a block and applied to the ledger. And finally, you can call put state so that the state will be saved back in the peer node. All right, so that was pretty straightforward, to implement a chaincode. Deploying a chaincode, on the other hand, gets pretty complex. Deploying chaincode used to be much simpler in 1.0 implementation of the architecture. But the team realized that it's not really giving each organization the power to endorse the agreement of a particular chaincode deployment. So a new lifecycle process has been designed since 2.0 architecture that on one hand makes it more powerful. So each participant of the channel has a say whether this chaincode should be adopted or not in the channel. But as a result, it's also gotten quite complex. So let's take a look at the multiple steps requires to instantiate the chaincode. So this example, we have three members within the channel. As you know, a channel is sort of a mini blockchain within Fabric. With Fabric, you can create any number of channels such that you basically have any number of blockchains. They're each separate from each other. They have their own ledger, they have their own state databases. So within this example, this particular channel, we have three members. And now let's say we want to deploy a chain code called my chain code -1. It's called my chain code -1. First of all, the number one step is we need to install the chain code binary onto the peer. And that's a step that each organization has to do themselves. It's an admin step that requires you to have admin access to the peer directly. So you can essentially upload the chain code binary to the peer node. And unlike some other protocol designs that require all chain code on all the nodes or all smart contract on all the nodes to be exactly the same. For example, with Ethereum, chain code itself is a on-chain data. So chain code, binary code for the Ethereum smart contract is a on-chain state, which means every node has exactly the same copy of a smart contract. Fabric is different. Fabric doesn't require all the chain code implementation from different peers, from different orgs to be exactly the same. This is very interesting. What's required is they should produce the same result when the same contract, when the same method is being called. So they have to implement the same interface because they will be asked to execute the same method with the same parameter, but their implementation can be different. That's very interesting. So in this example, org B is installing implementation A of this interface. Org C has a different implementation, it's called code B, and they install on their own peers. Org A doesn't even need to install that because they are not interested in endorsing chain code execution. They just say, well, for this particular chain code, I'll just replicate data. I don't have to be part of endorsing the execution. So org A doesn't need chain code at all, and org B, org C install different versions of the implementation. So that's install. Once we have that, then we have the binary of the chain code on the peers. The next step is all the orgs that wants to replicate transactions processed by this chain code needs to approve this chain code. So org B and C call their approve, so they can basically allow their applications to call their peer nodes to process transactions. Org A also approved it, even though it's not very interested in executing them, but still goes ahead and approve it. And this is when the policy aspect of the Fabric architecture comes into play. With every chain code instantiation, there is a policy. And the policy is part of the channel consensus, channel genesis block that says, this is the threshold before a chain code goes into effect, which means enough participating orgs must give the approval before the chain code goes into effect. So let's say for this chain code, our policy was set to be 100%. So all members must give their approval. So even org A is not very interested in executing the chain code, it still has to give the approval in order to meet the criteria of the policy. Okay, so let's say all of them gave the approval. The final step is let's go ahead and put it in action. That's called the commit. Only one member needs to call the commit once all the approvals are given. After the commit, the chain code is finally ready to be called to process transactions. And you can do this multiple times with other chain code. So that's deploying the chain code. We have the chain code ready to be called. Calling a chain code, there are multiple ways to do that. You can always use the native SDKs, and there are SDKs available in Golang, in Node.js, in Java for the client to use, just like you can use these languages to implement the chain code themselves. We also have API-based interaction with the chain code available. For example, Hyperledger Firefly is a top-level Hyperledger project. It's actually contributed by the Kaleido team. One of the components in Firefly is called Fab Connect. It's shorthand for Fabric Connector. It's a blockchain connector component in the Firefly architecture, but it can be used independently as well. So this gives you a REST API server standing in front of a Fabric peer, such that you can interact with a chain code through a RESTful interface, rather than having to write a whole bunch of code to do that. It also gives you an event stream so that you can subscribe to the stream and get events automatically delivered to you through either WebSocket or through webhook endpoints. You also have the choice of using Firefly itself to interact with your chain code. Firefly has a custom contract API support so that you can define an API to interact with your contract after you have taught Firefly about the interface design of your chain code, and then you can call the API to do that. We'll see both of these components in action. I'm not going to do a demo of the native SDKs because they're super nice tutorials and documentation around that. So I'm not going to go through that on this call, but I'll show you how to use Fab Connect and Firefly. So as I mentioned, Fabric SDKs, in particular, this project called Fabric Gateway, is a collection of all the free SDKs for the Golang, Node.js, and Java. It's compatible with version 2.4 or later. If you need to, if your Fabric is a 2.3 or earlier, then you still need to use the older versions of the SDK. Which are listed here. Separate projects called Fabric SDK Go, Fabric SDK Node, and Fabric SDK Java is compatible with version 2.3 or earlier. Using these versions of the SDK, the client is required to do quite a bit of more work compared to if you were using the network flavor, because the gateway flavor of the SDK utilizes the gateway node feature of the Fabric peer 2.4, which is essentially a submitting peer. That peer, you only need to talk to that single peer, which then dispatches your transaction to the necessary other peers in order to collect enough endorsement for your transaction. Whereas if you use the older version of the SDK, the client itself has to do all that. It needs to discover where other Fabric peers are and how to talk to them and contact them individually in order to collect the endorsements. Okay, so I mentioned Fab Connect. This is a high-level architecture description of what the Fab Connect does. As you can see on the left-hand side, it gives you really easy to use REST API endpoints. So you can use it to create identities with the Fabric CA, enroll the identities so they can be used to sign transactions. You can submit transactions. You can get query for transaction results, and then you can create event subscriptions. So the events get delivered to you through WebSocket or Webhook. So now let's dive into a demo of Fabric. So of Fab Connect. So as I mentioned, this is a version of Fab Connect within Hyperledger, and I've already built. So we have the binary already ready to go. We just need to launch it by giving it a configuration file. So before we launch it, let's take a quick look at the configuration file. Pretty straightforward here. A few performance tuning parameters, and then you tell it where is the storage for the receipts, because Fab Connect keeps track of the execution result of every transaction, both successful and failure, and stores them in receipts. So you can query for them anytime you want without having to go back to the peer node itself. So it offloads a lot of the work from the peer. It also has a storage for events subscriptions. So you can tell it, these are the subscriptions I created because I'm interested in different Chaincode, different events. And finally, you tell it where to look for the chain itself. And that is a configuration file that if you have dealt with Fabric, you should be familiar with, the common connection profile. It's a quite complex either JSON or YAML structure that describes basically the topology of the network. And this is required for the Fabric SDK, which Fab Connect is built on top of, to talk to the peer nodes and the orderer nodes. Okay, so let's go ahead and launch it. It's listening to port 3000, and because I've already tried it before, I have created a event subscription. It knows that from the database, and then it's listening to events based on the spec in the subscription. Okay, so once you have this running, you can look at the Swagger interface that's available, and this is the Swagger interface of a Fab Connect component. As I mentioned, you can query for all the identities with Fabric CA that's in the backend. So as you can see in the common connection profile, my backend is really on the Kaleido cloud. So my Fabric network is running in Kaleido, and I'm talking to that network from a local Fab Connect instance. So earlier, I was using this Swagger interface to ask my Fabric CA in the cloud of all the identities it already supports. And let's go ahead and create a new identity so we can use it for our transactions. Call it demo user. Then don't need anything else. It's going to be a client type of identity or you can skip it because the default for this API is client. So we created, it's returned us with a secret that then we can then use to enroll. That's another API. Tell it which user you like to enroll and then give it the secret. We're not going to use any custom attributes. And now it's been successfully enrolled with the Fabric CA. And the enrollment certificate has been downloaded to Fab Connect. So now we can use this user identity through this Fab Connect instance to submit our transactions. Okay, so submitting transactions is very straightforward. There's endpoint /transactions, and you do post on it. Let's first try a synchronous style. This will hold and block until the transaction has been mined. So the signer we set is demo user, and it's going to be on channel 0. Let me show you the Kaleido side of things, why we're using channel 0. So before this seminar, I've already deployed a Fabric Chaincode version to my blockchain, and in particular, there is a channel called channel 0 with my Chaincode implementation, and you can see it's been successfully approved and committed, and it's ready to go. And it's called asset transfer. So let's go ahead and call it from here. So the function is going to be create asset. The argument is first the asset ID, let's say asset 100. Pretty sure the second is yellow, and then it is the color, and then it's the size, then it's the owner, finally it's the value. All right, so let's give it a try. All right, so we're encountering an error. So I'm just showing you when there's an error with the Chaincode execution, it's reflected back to you in the response of the API. It's telling us it's having trouble passing the value, parsing the value of, I think it's the size property, and that's because it's supposed to be a number. So let's correct that and submit again. So now this transaction came back as a valid transaction, and at this point we know it's already been mined into a block. So that's great. It's very straightforward and very, very simple to submit a transaction using Fab Connect. We can also use a different style and say, my application requires me to send a whole bunch of transactions in a large volume. I'm not going to wait for each one to return. I'll just say, send it in and tell me how it went later. So instead, I'm going to say, don't block, and I'm going to use the returned ID so that I can pull on the transaction result. So this would give you a higher throughput overall. Okay, specify the channel and the signer.
You use the same ID, Jim. Asset 100.
Oops. Okay. Yes. And then I think that the result was telling us the transaction failed because the status code is 5,000, no error transaction. That was a failed transaction. Maybe try it again. Thanks, Nick, for that tip. Then query for the results. Interesting. Okay, I was expecting to see a transaction result here. So what is the problem here? Obtained receipt. Okay, if we have time at the end, we can look into this, but for now, let's skip it for so we can cover the other topics. You can also call query. So this will be just asking your peer for the latest state. So again, this is channel 0 and asset transfer. The function is get all assets, and we don't need any arguments for that. Strong read equals true means this Fab Connect under the cover will call all the peers in the network rather than just your own, and then tell you if the result all matches or not. So this gives you all the assets that's been created. We can see asset 101, 101 that we just submitted. Both have been created successfully. Somehow we're just missing the transaction receipt. Okay, so I mentioned you can also create event streams. So let's try that. We have a event stream that's created. So we'll just use that. It's a WebSocket type of event stream, meaning the client will be connected to the peer through to Fab Connect server through WebSocket, and Fab Connect can deliver all the events to it through this channel. And then once we have that, next thing we need to tell Fab Connect is what type of events you're interested in listening to. And this is what a subscription is for. You create a subscription to express your interest in the particular types of events. So over here, we already created a subscription that says, I'm interested in channel 0 of this chain code, and all the different events of different names, please tell me. So that's a existing subscription. We're not going to create a new one. It's all the same. So we'll just go ahead and connect to that from our client. Move this thing away. All right, so gonna use command line client that will act as our WebSocket client. So this is how you connect to WebSocket endpoint, and you have to express your interest by saying, please, I'm listening to this topic. So if there are events about this topic, tell me about it. As you can see, we already delivered a event. This is what the event looks like. Let me load this up to you so you can see it better. So as you can see, the event has the regular information, including the block number, transaction ID, transaction index. It's also got the payload itself. This is very useful because don't know if you know, all the payload back and forth with Fabric is all bytes. But when we created the subscription, we told FabConnect that the payload type for this event is JSON. So FabConnect went ahead and deserialized it into JSON and then sent it to us. So it's much easier to process from the client side. Okay, so we already got a didn't mean to do that. We already got an event delivered to us because of the transaction we submitted earlier, and because we said from block 18 onwards, if you have new events, let us know. So every time we had a new event, we're going to acknowledge and say, yep, I've seen it. Give us the next one. As soon as you acknowledge it, the next event is delivered to you. Both 38 and 39 are new as of the last time we ran this event listener. So FabConnect knows that the cursor position of each event stream. So even if your client sort of crashed, and then as soon as it comes back, FabConnect will pick up where it left off and give you all the events you may have missed as you were offline. So this is what it looks like. Our client came back online, and then we got delivered all the events we had missed in the meanwhile. So that's great. Using FabConnect, as you can see, it's very straightforward to sending a transaction with REST and JSON, and then listen for events that can be parsed into JSON as well. Next, let's take a look at Firefly itself. So Firefly is a much more sophisticated architecture. It's a bigger component that it's basically your system of record of all things blockchain. It knows how to talk to different kinds of blockchains, all the EVM-based blockchains, Ethereum, Polygon, Besu, Quorum, Arbitrum, Avalanche, you name it. If it's EVM-based chain, Firefly knows how to talk to them. Firefly also supports Fabric through FabConnect. And it's a pluggable architecture so that if you have a new protocol you need to support, you can just implement a blockchain connector right here, and you can talk to your new blockchain. And then what Firefly does is, on one hand, it allows you to submit your transactions through a RESTful interface, just like similar to what FabConnect does. But it's also has other high-level construct so that not only you can call your contract, you can also use it to manage your tokens, digital assets, NFTs. You can use it to manage your multi-party workflows. There are a lot of use cases within the enterprise space where blockchain is used as the orchestration engine to orchestrate a multi-party workflow so that all the transactions are globally ordered, and which is critical to a multi-party system. So we don't have enough time to do Firefly proper justice, but please take a look at Firefly documentation. We have awesome documentation online to see what it does. Right now, we're just focused on Firefly's support for custom contract. So let's take a look. I have a Firefly started locally. I created a stack for Fabric, and it's been launched. I've also deployed my asset transfer Chaincode to that stack. So the Fabric blockchain inside the stack has this channel created and the Chaincode deployed. So Firefly runs on port 5000. So let's go there and talk to Firefly. So this is what a UI of Firefly looks like. As I mentioned, there are many things that Firefly does beyond just doing transactions and tokens. But let's focus on the transaction themselves on Firefly. So you see over here, we have many events that shows that we have submitted some transactions to Fabric. Some failed on purpose, some succeeded. When it succeeded, you can see the payload and the result. When it failed, you can see the error messages. So what it requires to use Firefly is, first of all, let's go to, actually, let's use Postman for that purposes. It's about 2 steps that you have to, to do in order to have Firefly manage your custom contract. First of all, you need to tell Firefly about your API interface. So at this endpoint contract/interfaces, you describe what is the Chaincode interface. So you can create an interface with Firefly. Here, you're using a construct that's similar to JSON schema to tell Firefly, okay, there is a get all assets method that takes no parameters and returns an array of parameters of objects. There's another method called create asset and takes multiple parameters, and they're called by these names and returns nothing because it's a transaction. And finally, there's events. So I've already done the deployment. So the next step is, okay, so you told me about this interface. Now let's go ahead and create an API based on this interface. So there's an API that was based on that interface. You can see it was the ID of that interface. And you say there is a Chaincode instance on this Firefly channel. It's called asset transfer that conforms to this interface. So this is how you create an API. You give it a name and tell it where the Chaincode implementation is for this interface. Once you've done that, now you're able to call this interface. So notice that asset transfer was the name we gave the API. So now you can use it to call. So let's go back to our browser so we can use the wrong. It's not the right URL. Okay, APIs. Namespace and then APIs. What's the asset transfer? So we want the UI for that, which is here. Okay, so this is the every time you generate a new API, the swagger for that is generated for you automatically. So now we can use this endpoint. As you can see at the high level, there are endpoints to invoke for transaction purposes. There's also endpoints for query. This is just to get the latest value. So let's go ahead and create an asset. You notice that now, instead of, when we send in the FabConnect transaction, we had to remember the right order of the transaction parameters, like here, right? Because they're just a list of strings. But here you have the much nicer JSON object. So color will say yellow ID is S102 now. Demo user is the owner. Well, say Thomas, size 10, value 1000. Let's go ahead and execute. Now you are given back an object in Firefly that says, okay, I know about your transaction is pending now, but you can query for its results. Now, if we go back to the Firefly UI, we see now a new transaction has been submitted a few seconds ago, and result is success. And you can see the details of that transaction. So depending on your needs, use FabConnect if that's one of the components you like to use to build your application, or use Firefly, which is it's essentially your integration layer in your system of record for anything, for any applications that need to talk to a blockchain. Feel free to ask us any questions on Slack. We have a dedicated Kaleido Slack, or on Discord. Sorry, I may have gone a little bit over time. Back to you, Nick.
No, that was great, Jim. Really appreciate you sparing the hour for us today. Hopefully that was edifying to the rest of the audience as well. Just a quick synopsis from me of what Jim showed you today. A few areas where Kaleido, Firefly can really accelerate your journey. First, you need a Fabric blockchain. That is an incredibly non-trivial thing to do. Standing up those CAs, ordering nodes, peer nodes. Kaleido lets that happen with a couple clicks of a button, and all of those underlying complexities are completely abstracted. Number two, what's your lift as an engineer? You just need to bring some chain code to the platform. So spend some time thinking about your business logic, thinking about your environment, thinking about your global variables and your if this, then that type statements. And then number three, where do you want your events to dynamically be delivered, right? Typical practice we see is folks using things like triggers and serverless functions on AWS or on Azure, so that as you get these events, you're able to filter against different chain code names, different signers, different, sort of event signatures. And you can do one of two things. You can trigger downstream processes, or you can just park those events in a database that sits next to your application. So Kaleido is trying to remove all of the really hard things and all of the heavy lifting, and let you as an engineer, as a business owner, focus on your problem statement, focus on the actual UX and the application. As Jim mentioned, if you would like to talk more about your use case or any projects, you can reach us on the Discord, Firefly Discord. You can just go to kaleido.io. There's a chat bot, or you can email support@kaleido.io, and that will get routed to myself and our entire help desk team. So know we're a few minutes over. Really appreciate everyone spending the hour with us. And yeah, big thanks to Jim for taking an hour out of his day as well. So please stay tuned for, we'll send out this recording, and we're going to be revamping Tech Tuesdays going forward in 2023. And I believe we even have one next week. So more communications to come on that. And with that, I wish everyone a lovely remainder of their Tuesday. Thank you so much.
Thanks everyone for joining us. See you guys.